Okay guys, now today I wanted to talk you through a bit of kit which I've picked up recently, which is absolutely fantastic. You're going to love this. It's the SPL-LAB Next LCD. This is an all-in-one unit that does pretty much everything you could imagine and everything you could want it to do from an all-in-one sort of monitoring piece of kit here. You may know SPL-LAB for their SPL dB meters and also their smart voltmeters and smart monitors which can read, monitor and give you information about the amplifier's output, current draw, box rise, things like that. Basically what this is one unit. They've put all of their previous products together and you can use this standalone without a computer, or you can use it connected to the PC if you wanted to get a better screen and a better picture of exactly what's going on. Now when you boot it up, this is the first screen you get. It's got two ports in the back there which allow you to hook up a variety of sensors. You've got three sensors to choose from. You have got the power sensor, which looks like this. So this is what you connect to the amplifier's output, the speaker outputs, so from the subwoofer output, and this will measure the current going to the speaker. Through here is wireless, so you haven't got to make any additional connections in your wiring, which is really handy, and you can fit some nice thick cable through there, way thicker than your speaker cable is ever going to be. And it also measures the voltage from the amplifier's speaker outputs, which is connected to you there. The end of these cables just connect in parallel to the speaker's output, so it's all nice and easy. Measures current and voltage. Now those of you who will know that if you can measure current and voltage, you can calculate the power output, and because this is in real time, you can see exactly how many watts is going to your sub at any given time from the amplifier. So this is the power sensor. You've also got other sensors, for example the RTA sensor. So this is a very high sensitivity, wide frequency response microphone, which can be used for monitoring the harmonic distortion output of the speakers. It can be used for setting up your crossover frequencies in the car, from your mids, your highs, your lows, finding out exactly where all the dips are in the frequency response, finding out where there's harmonics, where there's little peaks and resonances and things like that. So when you plug this in, you get nice graph displays on the screen, which I'll show you in a little bit. And you've also got the SPL sensor, which looks the same as always. That obviously, just measures your dB in SPL. So you can hook up any two of those three sensors at any one time to the unit, and you can compare the readings from each of them on the screen. It splits it into two, so I'll show you that in a moment. So that this front screen is a configuration screen, which allows you to choose what type of sensor you've got plugged in here. So port 1 allows you to connect AC or DC sensor, SPL sensor or RTA microphone, the three there. Port 2 allows you to connect either AC or DC sensor or SPL sensor. You're not going to want two RTA microphones hooked up. That's not going to work at all. So we have calibration type. Now SPL-LAB are aware that the Magnum was brought out after they had built this already. The Magnum actually came out after this did. So you've got classic calibration type, which they have used all of their correct calibration with multimeters and things like that to get it absolutely spot on. So this is classic calibration, but then obviously they're aware that the SPL-LAB is a very popular name and the Magnum will be used throughout in competitions. So you also have a Magnum calibration type there, which is almost exactly the same, but what they've done in this calibration setting is they've set it up exactly as the SPL-LAB Magnum is set up. So all the readings and outputs will be calibrated in exactly the same way as the Magnum. So you can choose there how you want it to output its readings. You've got a backlight which can be turned on and off, and you have default settings there as well. So now I'm just going to go ahead and press the mode button. You've got some buttons down here. Mode will change basically the mode of the device. So the first mode on here is SPL Output. Now this is just like on the software, on the measuring center software for the computer. You have a sort of bar graph here which will display a range of frequencies here, and then the SPL output, which changes depending on how loud you are. So you can play in your vehicle a sweep from, say, I don't know, 80 Hertz down to 20 Hertz, and it will give you a bar graph of the frequency response, which will show your peaks and your dips, so you can set your crossovers correctly. for example, if you press the option button on this screen, it takes you to a live waveform, which I'll show you working in a bit. This will show you an actual wave, exactly what it looks like from the sensor. See exactly what it's picking up. And so from this you can see square waves. You can see when you're clipping, and it tells you a THD reading up in the corner here. So obviously with nothing going on at all, it's showing 100% THD because it's not measuring a sine wave. So everything is distortion that it's saying right now because there's no sine wave from it to measure. For the next screen, I'm going to power up all my power supplies and amplifiers to show you a bit better. Okay, so I use the SPL-LAB smart monitor over here, which is an older device, very cool, to power up the amplifiers. So now I'll switch to the next screen, which shows a split screen between the two sensors, which is, I absolutely love this. It's so cool, you can see exactly what's going on. So you've got on the right hand side an SPL sensing display here, which will show the frequency which the sensor is picking up, and it'll show the decibel reading. Now at the moment it sits and fluctuates on around its lowest reading because it's not got any sine to play with. And on the left hand side here you've got a true real-time power output from the amplifier, also showing the frequency there in hertz, and it also shows you the resistance of the woofer at that given time. Now we all know about box rise, and when a woofer is moving at different frequencies you get different box rises, and the speaker will present a different load to the amplifier. So using the voltage and the current calculation, it can work out the wattage and also the resistance of the woofer for that frequency. This has a peak hold as well on there, and you can also use this sensor not to measure the amplifier's output, but to also measure what the amplifier is drawing from the power supply. So you can change this to DC mode, and you can hook it up to the power input of the amplifier from the from the 0 gauge cable, for example, and it'll tell you how much power is drawing from the 12 volt supply. Now if I press mode again, it'll take us through the different modes. So we've already seen this mode, which we got through by the options button before. The next mode is just your power output if you hooked up a different sensor to the other side. And then this mode is a frequency generator, which I have scoped is completely perfectly clean, and you can choose whether to output a sine, a white noise or a pink noise. You can change the level of the output and the frequency obviously. So let's check that out now and play a constant sine so you can see all the other modes working. So I'm going to play a 33 Hertz sine. I like 33 Hertz. So press the function button here, turn the gain down to minimum, and my woofers here, which you can't see out of the shot, have started to move on the low volumes. I'm just going to turn the gain up a little bit. Stuff's starting to shake around on the table. Okay. So now I'm going to go back and change the mode, and we should be able to see all this stuff coming into play and working. Now obviously dBs we're not going to be able to read because these woofers are free air, so I will show you that in a moment off the Pioneer. But if we go to the power output here, you can see that at present on low volumes we are running 71 watts free air to this woofer on my desk, and the resistance free air is 3.1 ohms. Now I've got two woofers here hooked up and they're wired to 0.5. With the rise of them being free air, it bumps it up to 3.1. The more a woofer moves, the more the coil moves in the cap, then the more impedance rise you'll get because it's creating electricity flowing in different directions to the amplifier, so you get more resistance that way. So if these were in a box, or if I was to actually try and stop the woofers moving with my hand, if I can, these are 99 series DDs, so they're very powerful. So you can see here, if I stop them moving, the resistance actually goes down. Do you see that? 3.1. When I stop the woofers moving with my hand, if I put some pressure on the cone, down goes the resistance. Now if I was able to completely stop the cones altogether, they would actually be at 0.5 ohms on here, there or thereabouts. So very cool. Now if I adjust here, you can see how quickly it updates on the screen. So now we're pushing 28 watts, turn the volume up, 55, 70, 75, 80, 84, etc. So it is a very, very fast refresh rate, which is absolutely ideal for when you're playing music and when you're wanting to test out different gains and little burps and you want to see exactly what power is running. Very, very fast refresh. I am very impressed with this. Now let's press the mode button again. What I'm going to do is I'm going to stop the frequency generator here, and I'm going to plug in the RTA meter, and we're going to have a little bit of fun, and I'm also going to plug in the SPL meter. Okay, so I plugged the RTA in, and I'm just going to change the settings here. So we've got AC/DC sensor on number 2 and RTA microphone on number 1. Now I'm going to go back to the mode here. Now this graph here is showing exactly what the RTA microphone is currently picking up, and you can change obviously the graph bars here. I have to remember which buttons it is now. By pressing this button, we're changing the width of the frequency that's picking up on the bar graph. Very, very thin, or we can go very, very wide. Now here we go. So now it's scrolling through different frequencies. If I press this button here, this right button, it takes us through all of the different frequencies which it is picked up so far. So say for example you did a sweep and you played, I don't know, 1000 down to 60. You could go through each of the bars on the graph here and see exactly what decibels it picked up for that frequency. Very, very cool. Now if I press this button here, we can actually change the scale here of the graph. So here we've got a much wider bars, and then going down much thinner here, all the way. Okay, so if we press the option button, we get, as I said earlier, you get a live little oscilloscope here which will show you a live feed from the microphone or from the sensor. So you can see up here it displays the dominant frequency which you can hear, and it'll tell you the THD. So obviously my voice is not a completely clean cyan. Not bad to get about, I don't know, 30% THD there. It's a little bit weird when you're doing it with spoken word, but yeah, you get the rough idea. So let's play a sine wave. I'm going to take it to the frequency generator here, play 33 Hz again, get the woofers moving nicely, and then I should be able to hold the microphone above one of the woofers, and you should be able to see exactly what it displays. There we go. So this is holding the microphone directly above the cone of one of the woofers here, and we're getting a sine wave display, which, as you'll notice, isn't completely clean, and that is because the woofer is moving through air, so you're getting all the mechanical noises at the same time. It's not in an enclosure. They're all picking up, this is about 11, 12, 10 THD, with all the other noises going on in the room as well. So this is the RTA microphone, remember, it's not just designed for measuring bass, it's designed for measuring overall sound. So it'll pick up the sine wave which it's looking for, and it'll pick up on any other sounds as well in the room. So there you go, you can see it's picking up the frequency, and it's also picking up some other noises in the room, causing it to add some THD there to the wave, which you can see is not completely perfectly signed. The further I get away from the cone, if I place it right up close to the cone, I get 12%. The further I bring it away, the higher the THD gets. See how cool is that? Look at that. That is brilliant. That is a really good demonstration. Right up close to the cone, 12% THD. Slowly bring it up away. 14, 15, 16, 18, 19, 20. And the wave just goes a bit more out of shape until you're far enough away. Still picking up the frequency. Now we've got like about 42% THD. Yeah, 42% THD from quite far away from the cone. So that gives you a really good demonstration there of the frequency and the THD and how that's working. On the graph likewise, if I do this here, so we've got this large bar graph here. You can see the frequency range which is picking up there is in the lower end. If I press it again, you can see it spreads out, get much bigger here. That's for measuring a higher frequency. But for low frequency, you can see there the low bar graph. And if I press this button here, you can see if I scroll down to 31 Hz, which is what it's picking up, You can see there the decibel reading output. This isn't SPL dBs, this is dBA, I believe. Yeah, so it's going to be completely different to, like, you know, your SPL dBs. So right above the cone there, on about 50 watts, dBA is 118. Okay, so now I'm going to go ahead and swap out the RTA microphone. I'll just make a note, these are like network cable connectors, which I love, and are a vast improvement from the USB style connector because they stay clicked in, which is handy. I'm going to swap it out for the dB sensor, decibel sensor. Now I'm going to turn off all the amplifiers and the power supplies, and I'm going to run this test using the Pioneer Home Theatre 12 I've got down here off the Technics amplifier, which is in a box, so you can get some decibel output to see. We won't be able to see the power output obviously because it's all connected up to my LW5K, but you'll be able to see the decibel output. If I go back to the screen here and change this to SPL Sensor, here we go, and we're going to power up the Technics amplifier, and we're going to play some tones and see what this looks like. Okay, so here we have the SPL Sensor graph screen. The scale is set fixed 10 to 110, which is the pickup range of the sensor, and then along the side here this scale will change depending on your output. The minimum it picks up is around about 118, 116 decibels, any lower than that, and it's sort of like when it doesn't hear any noise, it just fluctuates around its lowest pickup here. So what we're going to do now is going to play a little bit of decaf, and we're going to see the frequencies here pop up on the screen, and you'll be able then to see how it's working. Now we've got peak hold function set on here, which I can turn on and off using the function button. For now we're going to keep peak hold off so we can just see how it updates. I'm going to hit play on this song. This is In the End, Decaf, Linkin Park. So you can see there, we're picking up some reasonably quiet bass there. I don't want to play it too loud. So we got 36 Hertz, down to 28 Hertz, and then down to 24 Hertz, which is in keeping with what Decaf has written on the file. So here we have a 28 Hertz little subbursts here. And those little subbursts are about 130, 131 decibels. I'm going to rewind the song back to the main part. Now on this one we've got the SPL, and this is going to give like a peak hold. So this is a way to set a specific time on the bottom here, say anywhere between 10 and 60 seconds or something greater, and it gives the competitor then a time scale to hit the highest frequency you can do, highest decibels you can do. So on here you've got a live display then again of the frequency and decibel output there, and on the other side of here you've got the power, so you can compare the two, which is very cool. If you press the mode button, this gives you an average dB/SPL score, which you can set a time again, and you can then give an average over a set amount of time of the decibels. So say for example you're playing music and you want to get an average over a 30-second blast of music, this will calculate the total dBs for that time period and provide an average. So guys, I hope you enjoy the general overview of the SPL-LAB Next LCD. You'll see this piece of kit in many of my future videos, hooking it up to the laptop, using it at events and competitions to clamp people's systems, show them exactly what they're running, what their box size is, measuring decibel output against power. There's talks of even starting a new class in the UK which includes power and kind of gives you a score based on how much power you're running and how much decibels output you get. So that even the little guy who's only running 300 watts RMS, if he's getting a decent dBs, whereas the guy running 10k is only pushing a 150, then you know, the little guy running 300 watts might actually come out on top. So that opens up the competition scene to people that haven't necessarily got humongous budgets, and allows them to compete with people that have got much larger budgets than them, but they may still have the knowledge and skills acoustically to create a box etc., and then they can stand a chance against people with a lot more of a budget. So absolutely fantastic bit of kit. Stay tuned for lots of more videos on this being used in my vehicle, which I'll do an update on very shortly, and at some events and all sorts of stuff, testing in the home, bench testing amplifiers, seeing how different speakers perform against each other, impedance rise, all sorts of things like that. So stay tuned, and I hope you enjoy the products. If you're interested in purchasing one of these, hit me up on a private message on YouTube. Also, I'll drop my email address in the description, as I'm the UK distributor for these. So if you're in the UK and you want to purchase one of these or any other SPL-LAB product, some fantastic range, I'll check out the website, link in the description as well. Hit me up and I will get in touch, and I'll be able to sort you out with one of these awesome pieces of kit.